Boker Tov, and good morning. My name is Jef Rייני. As Travis introduced myself, I am the operations manager here in Israel for Noble Energy, looking over all of our producing assets. First, I want to thank everybody for having us here today. It's a great honor to be up here, to enable ourselves to meet everybody, to share our experiences, and to learn what everybody else is interested in here in Israel. This conference is a subject that's kind of near to my heart. As Travis pointed out, my first experience here in Noble's Israel group was managing our operational readiness activities for our Tamar project. And I was basically given the simple task, the one line item that said, when we're ready to hit the start button, she's got to run. And so that's a lot more complicated than it sounds when you think back on it, but that's the task that I was given, and so it was a long road. You know, we had to do everything that's been discussed as far as procuring the people, getting all the procedures, the processes, all the services, everything that's required in order to handle our day-to-day operation, actually get the facility kicked off and running. But as you can see, you've probably seen in the news, it's been quite a success so far, and for the first year of operation, Tamar has maintained a 99% reliability and uptime, so that's kind of a world-class achievement there. Prior to Tamar coming online, I was given the opportunity to come over to Israel as our operations manager to look over our other producing assets and continuing on with our startup activities for Tamar. That was definitely quite an experience. I learned effectively how to use the term balagan during that time, and I use it frequently, but I'm in operations, so we do have those frequent scenarios. So I want to get in, and as I go through the slides, I kind of want to go through several things that we talk about and we look at, so we can show you, at least from Noble's perspective, what are the skills required to operate and develop and bring to fruition a project like Tamar. So real quick, just a history of Noble here in Israel. As Benny pointed out, we've been here since 1998. Our first discovery was the Noah field down in the south offshore Ashkelon. Right after that, we found our Mary B reservoir, where soon after, in 2003, 2004, we had installed our Mary B facility, where we flowed gas for the first time to our facilities in Ashkelon and Ashdod. In 2008, we then latered our onshore terminal in Ashdod, labeled AOT, where we do our last bit of processing of the gas before we go right to the grid. In 2009, we found the Tamar discovery. That's kind of what spawned a lot of these discussions and started the gas bonanza here in Israel. And then more recently, we've had our Leviathan and our Karish discoveries. We'll be looking at trying to find, develop, and bring the people here in Israel to help us bring these discoveries to market. I just want to point out that we have several partners in everything that we do. It's not just Noble, but we work very closely with our partners that are Delek, Avner, Isramco, Dorlan, and Ratio, who is a partner in our Leviathan opportunities. So what skills are necessary to operate a project like Tamar? In order to say that, first let me walk you through what Tamar is. Tamar can be separated into two categories. First, you have everything below water, and then you have everything above water. Everything below water is what we call the subsea piece. So on Tamar, we'll start with the wells. We've got 5 subsea wells. They're in 1,700 meters water depth. Operating in 1,700 meters of water depth brings complications associated with that due to hydrostatic pressures, the other variables about the climate there that you're working with. All these wells were drilled down to 4,800 meters, so they're not too deep, but they are deep. And of course we have high quality gas sands that we found that's related to the Tamar resource. Each one of these wells, based on the requirements for flow, were designed specifically for our projects. So, you know, normally you kind of, in the States where you have these large fields, you kind of have some cookie cutter type well programs, but these wells were designed specifically for their high rates. I remember back when I first broke out in the industry working for Noble, I was assigned 100 gas wells down in South Texas, and my best wells made 100 MCF a day, and I was super excited about that. But by analogy, these Tamar wells are all designed for 250,000 MCF a day, so they're world-class wells that take world-class technology and expertise in order to design these and flow these. All 5 wells flow to a central manifold that you can see there up in the left-hand corner, and then up 2 16-inch pipelines that take the gas to the Tamar platform. The pipelines might look on the picture as the most simplest piece of the subsea process, but actually they're quite complicated. When you're working in these subsea fields, one of the first things or the biggest things that you have to deal with is flow assurance. Flow assurance is the daily battle of assuring that you maintain the integrity in your pipelines to deliver the gas through the system. So there's 2 things specific to Tamar that we have to battle on a daily basis in terms of flow assurance. First and foremost is hydrates. Due to our gas composition at our conditions along the pipeline on the subsea area, we are in the hydrate region. And a hydrate is basically an ice plug, a methane ice plug that can form at temperatures well above the freezing point of water. And at pressures, it makes that even worse. So we have to continuously inject what we call monoethylene glycol, or basically antifreeze, at the wells consistently to mitigate against these hydrates forming in our subsea pipelines. The other big concern that we have with Tamar is rust, basically, or iron that forms on the inner walls of the pipe. Normally this isn't a problem on your normal subsea tiebacks, but because our infrastructure is 150 kilometers away from the platform, that iron builds up over that distance, and you have large amounts of iron coming to the top side. So we have a specific formulation in our MEG system, or the glycol that we inject, to help mitigate against this iron forming in the system and to lower the effects, because all that iron, when it gets up to the platform, it starts attaching to all the hot surfaces and clogging up all your production facilities. So that's a big piece of our flow assurance. And then it also provides another benefit. It allows that pipe to have a longer time in service due to the corrosion rates along the inner walls there. As you can also see, going back out to the field, you see 2 yellow lines. Those are our subsea umbilicals. Those provide the control system that the operators on the platform use to function the wells and the manifold subsea. You know, like I said, the wells are 150 kilometers from the platform, so the guys can't go up and touch the wells. These umbilicals provide low pressure and high pressure hydraulic fluids that allows us to manipulate chokes and valves on the trees and in the manifold. They also supply power that we use to power the control pods and the other electrical devices on the subsea equipment. Inside these umbilicals are also the fiber optic cables that provide the communication path so that we can have means to send directions and receive information back from the field. And there's also other tubing that allows us to provide as needed production chemicals to the wells, such as methanol, scale inhibitors, other sort of things that we might need to enable our flow assurance needs there. So on the subsea piece, it's actually a rather large piece of what our daily business is, even though you can't see it. Noble has dedicated boats that we have full-time with the ROV services in case we have an upset subsea. We can get to it quickly, or if we need to do any sort of inspection or periodic inspections that we do on a subsea basis. So that brings a definite expertise that we are building here in Israel amongst our own group. The other side of Tamar, like I said, is the above water piece, is what we call the top sides or the process piece. As you can see there, the subsea pipelines flow to the Tamar platform. The Tamar platform itself is actually The process is rather simple when you think about what we have to do subsea. The main purpose of the Tamar platform is to first separate gas from liquids and then separate liquids from liquids. So when we flow these wells, we flow a mixture of gas, any condensed water that comes out of the gas as the pressure drops, any condensed hydrocarbon liquids that drop out of the gas as we drop the pressure, and then of course we inject the MEG. So all of those fluids arrive at the Tamar platform. First, our process, we have to separate the gas from the liquids. We have to dehydrate the gas, and then we send the gas through our export line to AOT for the last bit of conditioning before we send the gas into the INGL pipeline that goes to our customers. The liquids is what makes Tamar unique from our older facility, Mary B. Like I said, we constantly inject MEG subsea to help protect against hydrates. And so when we receive that liquid mixture on the platform, we have to separate the condensate in the water from the MEG, because we want to reuse the MEG. We inject up to 70 barrels a day per well of MEG. If you equate that to gallons, that's 2 gallons a minute that we're injecting in each one of our wells. So that's a large volume. We've got quite a bit of volume subsea of MEG, so we don't want to lose it. We've got to regenerate it, recycle it, and reuse it. So that's one of the big activities that the Tamar platform undertakes. And with that, you have special requirements for chemists. We have a lot of services where we have to pull in the country for disposal of filters. We're a big filter user, and in any other services that we need to help us manage the MEG system. So that's basically Tamar in a nutshell. So now that we're familiar with Tamar, what are some of the skill requirements to manage a facility like Tamar from fruition to the operation stage of which we're at right now? And this is really kind of the life cycle of a upstream oil and gas program. First, you have the exploration phase. As we talked previously, we got to find the hydrocarbon resources. We got to determine if they're economic to drill for. Then we got to drill for it. If we're successful, we have the opportunity to complete it. Based on what we found when we drilled it, we have to take that information and decide on what sort of infrastructure we need based on the market that it's going to, the location of the resource, and the other requirements that might drive the development scenario. And then after that, once you do the development piece, you move on to the production operations phase. So the first phase, like I said, is the exploration phase. So we're here to talk about skill requirements. So based on Noble's experience, these are some of the skills that are required for this first phase of the project life cycle. You got to start out with the seismic piece. You got to be able to find it. In order to find it, you got to map it. So from that comes the geophysics. On the geophysics side, you have seismic interpreters, you have seismic processors, and then you have the seismic acquisition specialists. So these are all people that are PhD'd or mastered individuals that learn how to do their voodoo on taking sound waves and make a reservoir out of that. Once we've identified a prospect, then it goes to the geology side, where our geologists decide based on all the sources in the area, the geology of the subsurface that could possibly be in that area, on what's the likelihood that these resources could be there. Do you have a trap? Do you have a reservoir? Do you have a seal? And to do that, you have petroleum geologists, structural geologists, stratigraphers that look at the sequence of the rock face as you go down in depth, sedimentology that kind of tells you the timing for which those reservoirs were laid, basin analysts that look in the full big picture of everything's going on in the area, and then of course you have your well site geologists that will go on the next side that actually interpret it on the fly what we're finding when we drill the well. So this is the first stage. You got to have this in order to find it, unless you go and buy resources that are already there. But that's where we're at today in Israel. It's hard to find it. Noble and our partners have made it look easy, but it's not. It's quite a risky process to even get through this stage. The next stage in the life cycle is the drilling and completion stage. So once our G&G staff have identified an exploration prospect or a development prospect that looks like it might have a high chance of success, we hand it over to our drilling guys. The drilling guys will then take the data, the geologic data from the seafloor down to the depth of the reservoir and come up with a well plan on how what's the safest way for us to get the drill bit down to assess the viability of that reservoir. During this stage, you have a combination of drilling engineers that are predominantly mechanical petroleum engineers. You have your mechanical technicians, your electrical technicians, and your control system guys that are the guys on the drilling facilities that actually help the facility run. One of the more common names that you might hear about some of these guys are the roughnecks while we're going through the drilling process. For these big deep water floating drilling facilities, logistics is a big deal. You got to keep them supplied. You got to keep them running. So they hire quite a bit of logistics coordinators either on the facility or at the shore base where we're moving materials back and forth. Because here in Israel a lot of our things are deep water, these rigs that will be coming in to drill these resources require marine systems engineers and subsea system technicians to handle the marine side of these drilling vessels. The subsea technicians, since everything's subsea, you know there's daily checks on your BOP stack, your riser system, frequent daily ROV dives where these guys have to go and observe and maintain the integrity of their systems. And then on top of that, we need engineering techs, people to support all these activities and provide the help to all the engineers and the offshore technicians as we go through these daily activities of drilling the well. Then if you're lucky, we get to move on to the completion side. The completion side is actually quite different than the drilling side. Even though it might be using the same exact rig going from the drilling phase to the completion phase, the actual work is a lot different. The drilling guys just basically they want to make a hole real deep, real quick, and get done and get the cuttings out of the well and hold back pressure. The completion guys have a task of they have to assemble a bunch of intricate equipment together that they can't see in 1,400 meters of a well. So in doing that, they have to make a lot of quick connections. It has to be clean. They're using a lot of high technology to install downhole devices that help us flow the wells. So it's a different type of mindset and skill set than on the drilling phase, but you still have a lot of the base sort of positions and competencies needed during that part of the completion. So after we've drilled the well and possibly done a completion, we take that data and we determine what the next phase of the development needs to be. We get an understanding of what the reservoir rock looks like, what the gas composition or the hydrocarbon composition is, and that really tells us how we need to design our facilities in order to extract that resource and get it to the market. So just like on the Tamar phase where I said you have two phases, you have everything underwater and everything above water. On the development phase you have the same two general areas. You have subsea, then you have topsides. The subsea piece, it's a conglomeration of mechanical engineers and chemical engineers. The mechanical engineers help you design all your subsea hardware. The chemical engineers look at a lot of the flow assurance concerns on your gas composition or what other items that might be in your well stream to help design your subsea infrastructure. You have chemists that you work with to help you design what your flow assurance strategy is going to be. You have civil or structural engineers that help you design your pipeline system. Project engineers that manage the work and direct the activities and herd the cats on trying to get all these people moving in the right direction. And then you have, during the installation phase, you have your mechanical technicians, your I&E guys, your I&E engineers, your control system programmers, and your communication engineers. The subsea piece is highly complex. You know, you're communicating and operating a field that's in 1,700 meters of water, 150 kilometers away. So and it's hard to get to. You can't touch it once you've installed it. You can't put your hands on it once you've installed it. You have to do everything with an ROV. So this stage of the subsea design and planning and infrastructure installation is highly critical to assure the integrity of your operation moving forward. So there's a lot of focus on the subsea side during this development phase. On the top sides, the part that you can see, again, you bring a lot of the same sort of disciplines, but they've got a completely different focus. You've got mechanical engineers that are helping you design your rotating equipment or some of your other equipment on the facility. You have your chemical engineers that are helping you design your process. You have your project engineers, again, that herd the cats between the other engineering groups that bringing all of this together. You have your electrical instrumentation engineers. So, one big step from decades ago where the industry really cut its teeth offshore is we've moved to more facilities that operate automated or with programmed logic to manage the control system and the safety system. So more and more today, these electrical and instrumentation engineers are becoming more and more critical in helping us design our facilities and ensure that when we get them online, that they're actually going to operate reliably and not have a bunch of erroneous trips due to false indications and sensors or control logic that might be fighting each other. Then on top of that, you bring your technicians and the other guys that come in to help you commission the facilities. These guys will either start at the manufacturers, either at where you're building the skid anywhere around the world, where you're bringing them together and you do your integration, your last bit of commissioning activity offshore before you bring these facilities online. And then the last phase, which is the phase I'm more intimate in right now, is the operations phase. This is delivering the gas to the market. That's what the business is all about. That's what everybody's here for. People need the gas, and Noble wants to deliver the gas. So this is really the long-term phase of the project until the facilities are ready to be abandoned. In this phase, of course, you bring a whole suite of engineers. Every engineer that you had during that pre-phase, you have to have during the operations phase to help you maintain and monitor your operations, and that could be mechanical, petroleum engineers like myself, chemical engineers, electrical engineers, and civil engineers. You bring in all your technicians, such as the guys that we need trained at Rupin College. These are your mechanical technicians that help you on your top sides, keeping your generators running, your rotating equipment running, keeping your pumps going. You have your electrical and instrumentation technicians that are working with your control system, making sure your valves are working properly, making sure everything's kind of humming along and you don't have those erroneous trips on due to any erroneous process conditions. You have your process operators. These are the guys that walk the deck to make sure that your process equipment is maintaining the certain criteria that we need in order to properly process our gas, making sure we're not anywhere near our limits that could cause us an issue. And then you have your control room operators that take a much larger look at the entire facility and making sure that we've got the gas routed correctly. You have your logistics guys. So again, just like the drilling, the facilities are offshore. It's hard to get supplies out there. You have constant boats running back and forth. In order to be efficient, you have to have logistics people on the platform and logistics people on the shore to help direct that traffic. You have your health and safety advisors. These guys are probably the most critical people in my mind that you have on the facility. Our number one goal is to everybody to go home safely, or at least to go to bed safely every night. So that's the first phase before we get to the producing gas phase. So that's a big focus for Noble, is the health and safety side. And then you have your chemists that we use to manage our chemical system, like the MEG that I talked about on the third slide. And we have our subsea engineers that we have on staff that manage our ROV boat. They do our inspection subsea and help us with any troubleshooting that we have going on with that part of the system. So with all that being said, what are the keys to building a successful industry here in Israel? Well, first you have to have the investment opportunity. Rig rates in these deep water basins, in order to drill a well like a Tamar well or a Leviathan well, your spread rate for your rig will almost run you about $1 million a day. And with these wells, you know, the chance of success for these wells are normally well above 50%. So you have to have that opportunity. You have to have the resource. You have to have the market. You have to have the buy-in from the place that you're bringing the gas to in order to take that gas and make that risk in order to drill those resources and put in the time and effort in order to bring that gas to market. The next piece is you need a stable regulatory environment. So what we normally see happening in emerging basins such as here in Israel is that the industry comes in and finds these resources and starts moving rather quickly to develop them. You know, they have those expertise and those services in order to do that. But because of that fast-paced movement, the regulatory environment kind of goes through a learning curve of they have to pick up greater awareness. They have to learn what's best locally for them in order to properly apply the right regulations required to manage our business while we're here. And having those regulations are important, especially for operators like Noble and Woodside coming in, because it helps us to better plan our activities. It helps us to better train our people. It helps us to better design our facilities, so that when we get ready to put these systems online, then we have everything taken into account. And last but not least, probably the most important here is the skilled and competent workforce, which is why we're here talking today. As Benny mentioned earlier, right now we have 60% of our offshore and our onshore operations staff that are Israeli. We've been operating here since 2003, so we've been able to elevate guys and give the guys on-the-job training through our facilities at Mary B and AOT in order to give them the opportunity to move on to the next big thing like tomorrow. But we have other developments coming along down the pipe, and as we saw coming from Mary B to Tamar, we increased our manpower and we increased our services required by over 3 times than what we had this time last year. So as we bring on these new developments, you can fully expect that to actually increase logarithmically, just like the Mary B to Tamar transition did. So what's coming next? Everybody knows Levithan. Just like its name, Levithan's going to be a monster. Right now, conceptually, we're planning an FPSO as the first stage of the Levithan development. An FPSO requires about 50% greater personnel than what we're using right now to operate our Tamar facilities. You have the marine side piece, you have the subsea piece. You have a much greater attention to staff because it is a floating facility. So we have to get ready. We have to do what we can, working with Rupin, working with the industry, working with people that we can to get these people on board, to get them trained, to have them competent, so that when we're ready to hit that Leviathan start button, she's ready to go. So that's all I've got. Thank you, everybody. Toda.